February 30th, 2000, the dam containing toxic waste material from the Baia Mare gold mine in northwestern Romania burst and released 100,000 cubic meters of wastewater, heavily contaminated with cyanide, into the Lapus and some tributaries of the river Tisza, one of the biggest in Hungary. Cyanide is highly toxic, and is lethal to humans and other species even in very small doses. The cyanide-contaminated water has now been carried to the river Danube, which flows through Serbia, Bulgaria and Romania. The Hungarian Ministry for the Environment stated on February 14th that besides the ecological damage, the cyanide pollution in the river Tisza meant also a significant threat to the human health, because in the upper part of the Tisza the cyanide concentration was 100 times more than the limit value for drinking water. Reports from the area indicate that there has been extensive damage to the river ecosystem and its fauna. The Hungarian Environment Ministry has stated that, between Tisza and Szolnok, 80 and 100% of fish stock will be killed. Other wildlife has also been affected, including
extent of the damage. The European Environmental Agency describes the accident as the worst-case scenario for the region's rivers. The agency's own research has found levels of cyanide 4 times higher than first indications suggested. To date, little is known about the long-term environmental impacts of the incident. However, toxic and bioaccumulative substances, such as heavy metals, are common in wastes from mining activities. On the February 19th, the Hungarian Environment Ministry reported that Lake Tisza in the Hortobágy National Park, that has recently become a World Heritage Site, has been affected, as well as areas that are protected under the Ramsar Convention and reserves that form part of the MAB program of UNESCO. Cyanide is a highly toxic chemical compound that has been recognized and used as a poison for millennia. Today, cyanide is also used during certain mining processes to extract gold from otherwise unviable sources. In the year 2000, gold mining wastewater contaminated with cyanide spread into the Somes River of Romania and beyond after a dam holding the contaminated water broke. Because of its widespread effects, the Baia Mare cyanide spill is often called Europe's worst environmental disaster since Chernobyl. Cyanide and gold production. Since the 1960s, when cyanide heat leaching was introduced to the mining process, the toxic impact of gold mining has rocketed. The process involves pouring a cyanide solution over crushed ore. The cyanide solution percolates, dissolves the gold and carries it to solution ponds. This technique requires the use of large quantities of highly toxic cyanide. The cyanide solution is either reused, stored in a dam, or directly discharged into rivers or the sea. Toxic heavy metals and metalloids, such as arsenic, occur frequently in ores and can be released with crushing and leaching.
Most gold comes from lode deposits, also called vein deposits, concentrations of gold and other metals in the cracks of rocks. Lode deposits require hard rock mining, the process of removing gold-bearing rock, called ore, by drilling and blasting. Drill holes for explosives using what's called a long-hole air drill. The engineers know exactly where those veins of gold are, thanks to the mining company's geologists, who've studied the ore samples. The company collects these samples by drilling deep into the rock at 15-meter intervals. These diamond drill cores, as they're called, are up to 100 meters long and measure 3.5 centimeters in diameter. Gold in its natural state isn't pure. It's usually intertwined with silver or other metals. So the mined ore has to be processed afterward to isolate and extract the gold. After blasting the rock apart with explosives, miners use what's called a muck machine to transfer the ore to cars headed to the main shaft and then above ground to the mill. There, a crusher reduces the large chunks into smaller rocks the size of gravel. A mill then pulverizes them to the texture of beach sand. The factory adds a water and cyanide solution. Then another mill grinds it further into a mud-like pulp. This pulp flows into large settling tanks. The wet solids, being heavier, sink to the bottom. The water at the top drains to another area. Workers transfer the wet solids to an agitation tank and blow in air. The oxygen sets off a chemical reaction between the cyanide and the gold trapped in the ore, triggering the gold to dissolve and leach into the surrounding water. Zinc powder is added to solidify the dissolved gold.